All right. Here, this is your Ethernet switch, which again, there's no preventative maintenance. There's really no preventative maintenance for anything in here.
Right.
But I'll just go over each component so you're familiar with it. Your Ethernet switch, obviously that's for communications. There's really nothing to do there. Thermostat. Now right here, it's just like any receptacle. It's got a recessed GFI receptacle. Got your power 24 volt power supplies here. They're redundant. This is your redundancy module. Again, there's really no maintenance for those. Of course, here's your relays. And do you guys ever have to replace relays? Do you guys do that?
Our electricians.
Electricians do?
Yeah.
Okay. Well, they obviously just pop in and out. And one thing I was wanting to show you on these relays, there's a tab right there, and if you can either press that and that'll energize the relay. Well, there's a tab right here, and you can turn that flag right there, and it'll keep the relay on.
Okay.
So if your maintenance guy's trying to troubleshoot something, instead of standing here holding it or trying to force it in the PLC, you can force it by turning that flag.
Okay.
All right. Circuit breakers. Again, you know what circuit breakers are. Here you've got. This is something that your maintenance guys might have to replace in the future. You got your 120 volt surge suppressor, and these surge suppressors are make before break. So if this module goes bad, you can just pull that module out, and the contacts in there will close when you pull this out. So it'll still work without this in it. So if you don't have a replacement, just pull it out. So. All right, and here we got our UPS bypass switch. You guys, if your UPS fails, just go and bypass, and that shouldn't be a problem. Your PLC's right here. The only thing that you guys probably might really need to know about is you've got a switch here to stop, to take the PLC out of run mode, and then you can run it without outputs on, or run it with outputs. You want to keep it run with outputs. So if you ever have a problem and nothing works, if this is ever replaced, make sure that switch is in run with outputs enabled. And right here, you've got your intrinsic safety barriers. These are mostly for your radar level transmitters and your limit switches downstairs. So, and if you have any problems with those, I'm not sure if you guys have spare parts or not.
We do, but I don't know from what extent.
Right.
I do know that they gave Cease a bunch of spare parts, but as to what extent, I do not know.
Okay. All right. And the UPS, you'll probably never have to mess with this, but if you do, it's got a menu here. It's pretty self-explanatory. You just turn the output on. When you turn the output on, you'll hear a contact here close, and then when it closes, you'll hear everything power up, fans come on. So that's pretty much it for that. Now, right here, I'm sure you've seen this on the OIT. If you drag and drop, have you seen this?
Yeah.
And to get it back down, you just pinch it down.
You should be able to tap it.
Yeah, you can tap it too.
Yeah.
It usually works when you tap it.
Yeah.
There it goes. Tap it 3 times. So, and of course, you guys know how you got the open and close for each gate downstairs.
Yes.
And I don't know how much you guys use this. I see you're still in manual.
Yeah, that's actually that's the way that I operate it.
Yeah.
It is off of the buttons and off the manual.
Oh, okay. Okay. Now, let me grab this. You can have one of these. All right. You guys want to go? Now we're going to go over the functional description, and we're not gonna simulate this. We're just going to go over the functional description. All right. So we're no longer working off TIF flow from the plant. To start it, we're working off a level. So we'll just go to step 2. All right, so let's see. So when the old one was when the level and the influent would rise, it would trigger the CSO to close, correct?
Yes.
Now we're working off of influent level, correct?
Yeah, we're working off well, with the way I run it now, is I've got all my CSO gates down there closed.
Yeah.
And then the diversion gate back here, since it's not tied in to this, it does its own thing. So we just let it do its own thing and just keep the CSO closed.
Okay.
And then that will trigger when the CSO actually starts filling. When that level gets up, then that gate's going to close.
Yep.
And then it's going to automatically start filling the CSO.
Okay. So the knife gate is not functional from this system
No,
yet.
the diversion gate.
The diversion gate.
Yeah. And that's what we want to label it as diversion gate.
This switch here, Cody, was talking about auto manual switch. Should we have a label here saying what that auto manual switch does? Other than just, is that auto manual for the gates?
Yep.
Okay, all of them.
Yeah,
Yeah.
because honestly, we kind of operate it more of a manual type thing, anyways.
Yeah.
So.
Okay. Well, again, I'll leave this with you guys. This is a pretty handy table to have.
Right.
It gives you whatever this gate. Each piece of equipment you go down here and it tells you if the TIF for this that's changed. If the LIT is greater than set point, then it goes through and tells you which gates or valves should be open or closed in automatic. So this table here explains it, the whole document.
All right, so cell gates. Okay, when we open and close the cell gates, what color are they turning?
It
Are they
turns.
closed? Red is closed. you know?
Green is open.
Okay, all right, gotcha. So we do
And
it.
purple is travel.
Transition. Yeah.
Okay, okay.
You guys know about this screen here, right?
Yeah.
The solenoid valves. It's really good to help you troubleshooting a problem. If you think, hey, that gate should be opening, come to this screen, and it'll show you which, if the solenoids are on, then if they're on, that gate should be open. Correct.
Not knowing anything about that, but you got an auto and you got manual, so it's on manual. All that pretty stuff that you just went over, is it still, when it's on manual, is only that front work?
Well, when it's on manual, we have control over, pretty much, on closing and opening gates.
Right.
So correct me if I'm wrong, Cody. And the auto
So manual versus auto, does anything on the pre-touch screen
working auto.
work in not auto?
He's
Yeah, so-
saying, will it work in manual?
Can I open gate one?
Yeah.
Oh, excuse me. Let's see. So you're in manual. You flip that to auto. Then you've got control from here. This is actually, you can have remote manual control. That's what this is. If you leave this in auto, and if you leave all of these here in remote, then this is just manual control from the screen. There's no automatic control of the gates. Now, if you put it in auto, then you're in auto control, and the CSO will function based on the control strategy.
Right.
But if you want control from the screen, see, so if you're at the other site, remote IO1, and you want to build open closed gates from out there, I don't know if you'd ever do that, but if you want to do that, then you leave this in auto, then you'd have control out there. Because if you leave this in manual, you're going to have no control out there. So, all right.
Let's put our one back closed.
Now we've got two remote IO panels. There's one over at that building across the way. They're pretty much identical, except the one over there has got a reset button on it. So, and the inside's got basically it's duplicate components that's in the local control panel. So, not really much to have to see or doing here really. And at this point, we don't really have any IO wired to this. So, I don't know if it's something for the future you guys are going to do.
Yeah, I don't know.
So, all right. And of course, we got drawings in the doors of each panel. So, let's go through killing the power and bringing it back up. If you ever have problems, you hit enter, and you can arrow over to control, press enter, and the top one, turn on, off, or to bypass, press enter. Enter, and it'll pop up, turn on UPS, yes, and you hear the contactor in there pulling in. Let's see, the status. All right, and it resets the alarm itself.
Hey guys, I'm Cagney from Bar Environmental. So we're going to be going over our screen here. So first we have our screen controls, which basically tells you if the screens are stopped or running, if your local e-stop's triggered, or if there's any alarms or the lower field e-stop is triggered. You got your set points, which is basically your stroke second times, and then your stop delays. You can also go into alarm summary here and reset the alarms in this screen. So then you got your HPP maintenance, which is your motor run time. It tells you basically if any of your e-stops are engaged or disengaged, or your field e-stops, which are located downstairs. If your oil level pressure is good, if you have your high oil temp, very, very simple. Then you got your actual alarm summary screen that you can go into to reset your alarms from here. Then your technical assistance. That basically just gives the loading company information, the project information, the system, the project manager from everything, your system process, and a phone number and a website. So you can run these in hand mode, or you can run them in auto. Hand mode lets you manually run them. Auto is going to kick on as it sees the floats down the stairs from the low to the high level to the high level, in which the system's going to actively engage.
So what is that?
Yeah. But that's pretty much, it's pretty much all I got on this.
System high level, what is that telling us?
The system high level, so you're past the low level float and you're to the high level. So the system high level right here is going to be your high level float engaged, and it means the system's operational. If your oil temp gets too high, it's going to tell you.
All the Vega level transmitters, they've got a piece of paper that's in the junction box, and you'll see right here, that's the Bluetooth code. Okay. You have to have that to get on. If you lose the code, we've got it documented on the calibration sheets, but if you lose the code, you have to call Vega, and so you have to jump through a lot of hoops to get that code. But once you enter the code, your phone will remember you connected to it, so you only have to enter it once.
Do they all have the same code, or do they?
All different. But like I say, once you put it in once, that's it. So if you want to, we'll connect to. All right. So if you go setup and diagnostics. Okay. Allow. Allow. I don't remember doing that. Let's go back to the software. All right, now let's do see if it finds it. Yep. Okay. So I believe, let's connect to 3012. Yep. All right, there you want to put in 673908. All right, now here's the menu for if you want to set up the parameters. Like you won't have to do any of this, but here that's where you set the loop name, 3012, application. It's just a tank, liquid, unit. You got feet, degrees Fahrenheit, adjustments. This is where you set the distance. So it's 21.64 feet to the bottom, empty. And then 11.64 is going to be full. All right, let's see, diagnostics, simulation. Oh, yeah, sorry, you drive, simulation. All right, now hit start. Now, you can slide it back and forth. Or you can hit, I believe if you hit right here, you can type it in. All right? And you'll see that change upstairs on the OIT, obviously. Now, if you leave it in termination or simulation mode, it should terminate the simulation after 4 or 5 minutes, but I always just terminate simulation. All right? Now, if you come back and you connect to 3012, your pin's already in there, so you won't need it again. We'll put this back in the junction box so you have it. And that's pretty much it, man.
Okay, here you've got your main breaker on this side. There's also a breaker on the other side of this same panel, other door on the back side. Basic stuff here. Engine oil dipstick tube. Primer for your fuel system, for your primer pump there. Oil fill cap is up here on the top. You ever need to top it off or anything. You've got auto, off, and manual. You also have the same thing on the key switch. You have an auxiliary e-stop, an auxiliary shutdown. Menu's all the same. That's your engine, which gives you all your basic engine information, RPM, coolant level, oil temperature, your run hours, all the basic info. You can scroll back out of that, go to generator. Gives you your generator voltage when it's running, your amps, your KW, KVA, power factor. You can scroll back over. This is settings menu for adjustments in voltage, date and time, exercise, all that stuff. Alarms are the same way. If you get an alarm, you have to scroll up to that and off, hit your check mark, e-stop, check mark, it clears. You go back out of that menu, you're good to go. Once all alarms are cleared, you can go back to auto, you get the green light, and everything's ready to go.
All right, so inside this control panel is basically the same thing that we have at central. So, power supplies, redundant power supply, PLC, and over here is that switch I was telling you about right here. Stop, run IO. So if they have to replace the processor or something for some reason, you can't get the CSO to function, you want to make sure that switch is in run IO. So, if it'll run, you just won't have any IO.
Right, yeah.
So,
Question on
yes,
that.
sir.
Are any of the PLCs that you guys have put in, are they password protected from y'all's end?
No.
Or anything like that?
No.
Because right now we're dealing with that situation at Ham Road.
Oh, okay. Yeah, we don't put any passwords in our PLCs or function blocks. They're all open, so open to you guys. I think contractually they have to be.
Yeah. Yeah.
And these are a little different surge suppressors here. These are for your 4 to 20 analog signals. And again, these are make before break. So if you have a problem, they're really hard to get out. But these modules will pop out. And so if you lose an analog signal and you don't have a spare module, just pop the module out, and your analog signal will resume working. So that's just something you might want to tell the maintenance guys. And again, with the relays right here, you can press. We were talking about open and gate partially. If you go to your drawings, you can find which control relay you need to push in to partially open one. Like I say, you can press it, or there's a little tab right here, a little plastic tab. And you just break that little plastic tab off with your thumb, and then you get a screwdriver and you can turn that flag. And when it's turned, it's forced on. Yep. So let's see here. And again, we got our intrinsically safe barriers down there. You shouldn't have any problems with that, but if you do, there's no dip switches or anything that need to be set. You just Just replace them, wire it back up, and you're good to go. And these, if they have to be replaced, the terminals actually pop out, so you don't have to rewire it. You can just pop all the terminals off of the base, put your new intrinsic barrier in, and plug your terminals back in. You're good to go. And I don't see much need in cycling this again.
Yeah.
But you got your UPS and bypass. And this is your main breaker right here. So if you have to kill power for any reason, just flip that. And again, this right here, make before break. This is your 120 volt surge suppressor. If you lose this, just pull this out, and when you get a new one, replace it. All right. Any questions about anything in here?
No.
All righty. Yeah. All right. Over here is the same setup as you had in Central. You got an overview, your inlet structure. Here you can control your valve, manual, auto, and this is actually a 4 to 20 valve, modulating valve. You can command the position here. Let's see here.
Anything in pink you can change on there?
Yes, sir. Anything in the pink is a set point that you can change. All right. I'm going to go inlet cells. We don't have it. They're hard. We don't have the physical push buttons on this. We've got local control stations downstairs with the buttons and selector switches for manual control. All right. Let's see here. Odor control. Again, I believe this is basically feedback only for the odor control system.
Yep.
No control here.
No, it's all out here.
Right. Okay. Your Sydney Street regulator. You got your set points, your spans, your levels. We can go through that when we step through here. Alarm summary screen, alarm history. Red's when it's active alarm, green's when it's cleared. So that's why summary we have no active alarms. All right.
Now you said that there was local controls down there.
Yeah.
I believe we didn't install new ones down there.
Okay, so this does have the existing. There's physical buttons down there, so if something happens up here to the OIT, you can open.
There's not any. I don't believe there is on cell gates.
Okay.
There is on the effluent.
Oh, okay.
There.
Where's your effluent?
And then there's the one. There's the effluent one down there. There's the one that ties together the two cells.
Okay.
There's that one.
So you do have a way to physically open
Yeah.
and close the cell gates if you lose your OIT. If you lose your OIT, well, your VT SCADA is only monitoring only. I don't believe you can have any control from your VT SCADA. So if you lose your OIT, you can still open and close them downstairs, or push come to shove, you can get your drones out and force the relays on. That's a last ditch effort to get it to work. So, but anyway, we can go through the overview here. All right, so facility activation. When the Sydney Street gate is not closed, and there's a limit switch here to show when the gate's open or closed, the inlet valve position command will be set to 20 milliamps. So the CSO inlet gate will be 100% open. All right, then we'll wait 2 minutes. Excuse me. Yeah, we'll wait 2 minutes. And then when the Sydney Street level gets above the operator adjustable set point, we'll tell it the inlet valve position just based off the level at Sydney Street. So the valve position command will be updated at an interval defined by the influent gate adjustment delay set point. Let's see here, just okay. Let's see, and if the Sydney Street level LIT 7015, which you guys don't use the tag numbers, exceeds the gate closed level set point, the gate will be closed. If the Sydney Street level falls below the gate open level set point in percentages, the gate will be open. Now, facility draining. Let's see. You've got pumps on here, right? How many pumps do you have down there? Two pumps. Okay. Each pump. Let's see. The drain control is independently controlled by the each cell level. So you've got 2 cells downstairs, correct? On this location. Okay. And they're low level signal.
Level is 4, but it's 2.
It's 4. Okay. They're combined. Is that correct?
Yeah.
Okay.
They're combined.
Okay. All right, so once the level rises above 2.67 feet and then falls back below 2.67 feet, the pump will be called to run until the low level float becomes true. And so, so we don't really have any control. It's based off of floats down there.
Yeah. Right now, the way we do it is when it's full, your level is going to be, say the CSO is completely full, it's going to be right around 10 foot. And then we'll go on here, we'll open up the, what's under cells? Yeah, we'll open up the drain valve. That'll drain it down to 3 feet.
Okay.
And then once it's drained down to 3 feet, that's when you use the pumps to pump the rest of it out.
Okay, so it's 3 foot now to 2.67.
Yeah.
Okay. All right, that made a change then. All right, and you put the drain pumps in auto down there to control them. Drain pump starts, stops, got that. Simulate low flow, did that. All right, stormwater screen. Let's see, when the stormwater level at LIT 7012 rises above 5.3 feet, the screen will be called to run until the high level falls below 5.3 feet. The screen will be called to run if its auto signal is on and the oil temperature high is off and the low level oil is off and the motor overload is off. And I believe there's a control panel downstairs for the screens, correct?
It's right out here.
Okay. All right. All right, tipping buckets. Tipping buckets are controlled in sequence. The sequence below will be started when the cell's low flow input turns off. So bucket 1 called to tip. Are you guys running these tipping buckets in automatic?
No.
Okay.
We just turn them to open, which opens the solenoids. And then we go down there and turn each bucket on manually.
You guys aren't doing any automatic control of tipping buckets, are you?
No.
Okay. You've got automatic functionality here, but.
Right, yeah.
All right.
Does it have some control over the sampling as well, like, or does it just read what the sampling is? I just saw that part there on the screen.
Yeah, it reads it. So whenever that level, whenever your cell gets full, 10 foot, and it starts going out the effluent, then it starts counting down from 600, and it takes a sample every 10 minutes. But it doesn't. You don't have any control of the sampler off of this. The sampler's its standalone thing. It just gives you a thing of, I think it'll tell you how many samples it's took. And
some of the sites we had inputs for how many samples were taken. Some of the sites we did not.
Right. Yeah.
And I don't believe this site we had that.
I think this one just shows it counting down.
Right. Let's see here. And again with these cells. Let's see here. Tipping bucket, motor control, inlet structure. So we don't have control of the cells opening and closing the gates from the screen, do we? For William Street? I don't believe we do.
Yeah.
Which one is it? Tipping bucket, tipping bucket. I didn't start up this William Street.
Oh, no drain pump, tipping bucket, drain valve. No, you're out. I don't believe we do.
This would be the only site that we don't have control
Yeah.
over the cells. That's going to be manual downstairs, correct?
Yeah.
All right, so we just, okay. So the control narrative for this site's a little bit different.
Yeah.
Okay. All right, well, do you have any questions about? There's not really a lot to this site.
No, this one was really simple.
Yep. And then see setup. Does this one do you have the card in this one?
There should be a card back there.
Okay.
We didn't put radar down there?
Not on this one. I don't know if it exists already.
No, there's no drawings.
Yeah.
There's no level indicator to it, right?
Yeah, there's no problem.
But that
They
was
must have
existing.
just, yeah, they
There's-
must have just pulled off of that to read it
Yeah,
on there.
There's no Vega radars. Right.
Yeah.
Okay. Well, that's pretty much it for this. If you have any questions, anybody have any questions on control of this one? All right.
All right, this unit has 2 breakers. The main is here. There's another one on the other side that's identical to this one. So if you ever at the switch have an auxiliary 2 or a source 2, fault, and this is running, check breakers first, obviously, make sure you don't have an open breaker. Other than that, and this basic engine stuff, here's your oil dipstick if you need to check the oil. If you ever run into a situation where it's in an overcrank scenario, this is your fuel pump, lift pump primer. So if it's an overcrank not wanting to start, you can start there, trying to reprime the system and get it going. Oil fill cap is up here in the top, front valve cover. Start with the basics. This is your on-off switch, key switch. This is an e-stop. You've got an auxiliary shutdown switch here, and you also have on, off, and manual here on this side. If you scroll through your menus, screen will light up there, hit your check mark. That's your engine information. This will give you RPM, coolant level, coolant temperature, and your run hours. You can scroll down, you'll get fuel level, oil temperature, pressure, all the basic engine information. Battery condition, good. Tells you that your external charger's on. Hit the back button, scroll over again, you'll get generator information, you'll get your voltage, your amps, KW, all the information on that side. Hit your back button, go over again, you'll go into settings, which stuff you can't really mess with without a code anyway. The biggest thing would be alarm clearing. Like right now, it's got a high fuel because that cannot be cleared until the fuel runs down. But like right now, it's in alarm. That's why you have this flashing. You have to scroll over until it highlights it, hit your check, so you'll have high fuel level. And you can hit the check again, and if it's something that's not latched, it'll clear. So like in a situation where like maybe you guys need the generator in an absolute emergency, if it's in low coolant level, obviously check it. If it's low, put it in there, clear your alarm, it'll be fine. If it's full of coolant and it says low coolant level, you got a problem. That's something we have to fix. Overcrank, same issue. If it's in overcrank, that means it's went through 3 complete crank cycles and didn't start. If there's no leaks or anything crazy, you can go through here, hit the alarm button, hit acknowledge on your overcrank, it'll try it again, in case we're not here or can't get here and you got to have it quickly. Let's see. That's pretty much it on the controls. Oh, to acknowledge alarm, you have to be in off. You have to go to off and then cycle up to that, hit the check mark, hit acknowledge, and then back in auto to clear everything. But as far as that goes, that's pretty much it on the controls.
All right, so the OIT is the same OIT that you have at William Street, exactly the same. So we've already gone over all of this. This is Sydney Street, correct? Okay. All right. So I don't believe this one has got logging capabilities. Well, it's capable. It doesn't have a card.
Yeah. Well, the cards at the card at Williams is going to log.
Yeah, right.
For here, so.
Right. Okay. We'll just go over the hardware components again. And PLC, again, the switch, very important. You'll probably never see it not on, but again, in case maintenance happens to replace one of these and they don't know to flip it over, I don't know. Just it's good to know about. And again, the surge suppressor, that one made the break. This is your main circuit breaker. If you have to kill power to it, just flip that It'll kill the power. You will maintain power off the UPS. So if you kill this, just leave it, put it in bypass, and that'll bypass your 120 off of your UPS. And again, your circuit breakers. This is your power. Whenever you have 120 volts, this relay turns on and gives you your 120 volts. So this is your power fail relay. Again, we've got another 4 to 20 surge suppressor here. That module does pull out. And your power supply, redundant power supply, redundant module, your GFI outlet if you ever use it. Again, it's got the reset if it's tripped. And here's your temperature. If you ever get high temp, you can adjust this if it starts becoming a nuisance.
Okay.
And here's your intrusion switch. And UPS, we've already gone over the UPS. And that's pretty much it. There's really no controls out here. All the controls handled from William Street. So I believe all this does is open and close one valve.
Yep.
And level the feedback, I believe. Yeah, level. And that's pretty much it for this one. All right, Carter Street regulator training. All right, so the OIT, this is the same OIT that's at Carter Street CSO. We'll go over the functionality of the Carter Street, the functional descriptions when we get to Carter Street. But anyway, okay. So inside the panel, this panel we've got these are the Siemens multi-rangers that belong to the city. Yeah, it sure does. All right. Your PLC energy pack, redundant power supplies with a redundant module, Ethernet switch. Again, your 120 surge suppressor. This is your main breaker, so if you have to kill the power, flip this. And again, if you want to bypass the UPS, just put it in bypass. That'll kill 120 volts. Breakers, self-explanatory. The 4 to 20 surge suppressors. Again, these modules pop out. And it's mate to break, so if the module goes bad, just pull it out, and you won't lose any signals. You got your intrinsic safety barriers here. If they need to be replaced, again, the terminals pop off. It's pretty easy replacement. No dip switches, no configuration. That's it for this. All right, Carter Street CSO training. All right. So this site activates. This site activates when the inlet channel level rises above a operator adjustable set point, and then once it overflows high enough, it'll overflow into the flat screens. Let's see here. When LIT 2016 reaches an operator adjustable set point, slide gate 2019 will open. And 2019 is regulator control. 2019, the regulator diversion gate valve 2019 will open. Let's see. When LIT 2019 is greater than the LIT 2018, which indicates backflow from the river, slide gate 2019 will close and 2018 will fully open. 2018 is the bypass valve that's no longer there. So, yeah, it's gonna go out of there.
What's up? What'd you say, 25?
The bypass gate that we talked about at the regulator over there. Same thing here. It's also 2018. 2018. Yeah.
All right, let's see. Once the facility's been activated, slide gate 17 and knife gate valve 2017.
Should be the diversion and the knob gate here.
Yeah, will remain closed for an operator adjustable duration. At the end of the duration, if LIT 18 falls below an operator adjustable set point, then knife gate 2017 will open and slide gate 2019, which doesn't exist anymore, will close. Slide gate 2017 will reopen, and knife gate 2017 has remained open for an operator adjustable duration. Once slide gate 2017 opens, controls based on the LIT 2018 will pause for an operator adjustable time. It's initially set to 1 hour. And let's see. And it's still set to 1 hour, or set at 1 hour time for reactivation. Whenever slide gate 2019, which doesn't exist, and slide gate 2018 will partially close to an operator adjustable close set point. And again, in these documents, so I'll give you the documents. This graph here will tell you which gates should be open and closed. So I think you know all that, but it's good in the future if anybody else needs to know how it operates. This graph will break everything out. Alrighty. All right, the drain sequence initiates when you press the drain button, and then it'll wait an operator adjustable set point or time. Right now it's set for 30 minutes. After 30 minutes, it'll open each cell. After the cell level is less than the operator adjustable set point, or it's been 60 minutes. Again, operator adjustable. It'll step through each cell. Then when the disinfection level chamber is below the operator adjustable set point or 60 minutes, the drain is finished. You got anything else you want to add? That's pretty much it.
That's pretty much it.
All right, look in here. We got an emergency. This is an emergency call button on the front of the panel. All righty. Again, we've got our PLC and the switch in here we talked about. Let's see here. Ethernet switch, 24-volt power supply with redundant module. Again, the 120 filter, it does pop out. This is your main breaker if you need to kill power. If you don't want to turn the UPS off, you can flip this. Just keep this in UPS, kill this breaker, and you'll kill 120 volts. Intrinsic safety barriers, if they need to be replaced, terminals do pop off, easy replacement, no configuration required. Your relays here, it's got an override. You can turn them on and off right here, or there's a little tab. You can break the tab and then twist the flag, and that relay will be on. Over here, let's see what we got here. This is just the termination cabinet. Again, we just have a 24-volt power supply, relays, terminals, and your intrinsic safety barriers are here for the floats and solenoids. Alrighty, that concludes training here. All right, 19th Street CSO training. All right, so it's got the overview screen, and so the fill drain set point, when the regulator level exceeds the operator adjustable level for 60 minutes, which is all adjustable, operator adjustable. When it exceeds it for operator adjustable set point or time, 60 minutes, you start your fill sequence, and the cells will all close. And that's pretty much it for the fill sequence. There's not really much more to that.
No, that's pretty much it. Once it sees it hit the regulator, it will close everything here.
That's right. The drain status. To drain, hit the drain button. It looks at each cell level individually. When the cell level is less than operator adjustable set point, or it's been 60 minutes, which is also operator adjustable, it'll move to the next cell, and it opens the drain gate for each of the 4 cells. When the disinfection level is less than the operator adjustable empty level or operator adjustable time 60 minutes, it'll stop the drain cycle. And and the drain cycle can't be repeated until the max drain time operator adjustable has been exceeded. What else do you think? Anything else that needs to be covered on this? That's it.
Should be it on this one.
Intrusion alarm. We got that's because we got the door open. All right, and we got the solenoid screen, which shows you which solenoids are energized. Makes it easier to troubleshoot and know what's going on. Let's see here. We've got an emergency call button on the front. Here we got the PLC. Again, the switches. If you want to make sure it's in run with I/O. Got redundant power supply with redundant module, Ethernet switch. I don't know if you can see this now. We got a phase monitor over here, and we actually control the pump side of this panel. So we got 2 pump contactors with overloads, control transformer. Let's see. We've got a 120 volt surge suppressor, which make before break. So if the module goes bad, just remove it and you'll stay up. This is the main circuit breaker. Let's see, breakers, relays. Your relays right here, you got buttons. You can push your button, push it in, and it will. It's the same as being energized. You can break the little tab off, turn the flag, and it will force that relay on. And I believe that's it. All right, 19th Street regulator training. All right, so we've got the OIT. The regulator, you can see the CSO set points from the regulator. However, you cannot see these set points from the CSO. Let's see here. All right, so when the regulator level gets above 2.4, you say, that triggers the CSOs to fill. Okay. And there's a valve. Which valve is it? Regulator. All right, so it's the discharge gate. The discharge gate, SLG 1016. When we're in an overflow condition at the CSO, we open discharge gate SLG 1016 to discharge to the river. Okay. All right. And that's pretty much all the controls of the regulator. Okay. All right. See, set points. This is set points for the actual CSO for filling. The regulator set points. K value. That's not. And you guys don't need to set the K value. That's just used to calculate the flow over the weir. Let's see here. The actual regulator chamber, actual effluent chamber level, regulator chamber level for control, effluent chamber level for control in feet. These are feedbacks, and you've got simulated, which we're not. You don't need to ever use the simulated. Overflow differential, and the overflow differential comes from the difference between these two ultrasonics. Let's see here. That's pretty much it for this. Now that valve is, we said this SLG 1016. The controller for SLG 1016 is actually laying inside this control panel. And so we didn't provide, this wasn't provided as part of this contract. However, it had to be put in here just I'm not exactly sure why it wasn't mounted anywhere else, but here it is. So we've got the same PLC, power supplies with redundant power supply, Ethernet switch. Let's see, 120 surge suppressor. This is your main circuit breaker. Let's see here. This has got a different UPS, a little smaller UPS. It's mounted on the door, so you don't have a bypass switch on this panel. So, and we got two intrinsically safe barriers and one analog surge suppressor. And that's pretty much it for the regulator. All right, CSO CSO training. All right, so the inlet structure, this is basically feedback. It tells you if you're low pressure, ventilation alarm, combustible gas alarm, 1 and 2. Gives you your ultrasonic levels, feedbacks rather, and your status for your temperatures and power. All right, so CSO control. So feel, when the pump station level exceeds operator adjustable set point for the start level, then it'll activate the filling mode, which will close. Where is it? It'll close the diversion gate SLG 4017. The inlet drain gate will stay closed, right? Okay. All right, and then the other valves, the other gates, if they're not closed, they will close automatically to fill. All right. Then, once we reach the pump station level stop filling, then we just stop the filling sequence. And to go into the drain sequence, you hit the drain valve to initiate the sequence, and then each cell, after 2 minutes operator adjustable delay draining time, it looks at the level of each cell, and if it's less than 0.1 operator adjustable, or 60 minutes set point, which is also operator adjustable, it'll move to the next cell and it opens the gate and drains it. So then after, let's see, it gives you a max time of set to 5 minutes for drain disinfection, again operator adjustable. And let's see, anything else on here we really need to discuss?
Just, I guess, solenoid pages, which now the disinfection is not gonna, it's on there, but it's not gonna drain because it drains through that mud valve, which is not hooked up to that screen.
Okay, right.
Because we do it manually.
And the mud valve, we're going to talk about taking the mud valve off of here completely. The alarms for the mud valve, right? Because we don't have any electrical, it's not wired up at all.
Right, yeah, no,
Totally.
it's not wired up at all.
Okay.
I mean, at least we could at least hide it from the screen.
Yeah,
That
yeah.
way, if we want to put it back later,
Yeah.
or at some other point in the future, we can.
Yeah, okay. And let's see, we got the solenoid screen here. It tells you which solenoid's open so you can help troubleshoot or see what step you're in. Or if a gate's not opening, you can come here and say, well, the solenoid's on, the gate's not opening, we have a problem. All right, so inside of here, again, we've got our PLC processor, the switch here, make sure it's on run with IO. Let's see here, UPS bypass switch, Ethernet switch. This is a fiber media converter. GFI receptacle, of course it's got the reset on a typical GFI. 24 volt power supply, redundancy module. We've got the 120 volt surge suppressor. Again, make before break. If this module goes bad, just replace it. Alrighty. This is your main circuit breaker. Let's see, here's your relays. You can push the orange button to temporarily turn the relay on, or you can turn this flag and it'll turn the relay on, keep it on, forced on. Here you got the analog surge suppressor. Again, the module pops out and can be replaced. Here we've got our intrinsic safety barriers. If it needs to be replaced, these terminals pop off. It can be easily replaced. There's no configuration dip switches to be set.
Tyler, what are those wires right there?
This, I'm not sure what those go to. I'd have to ask Ian what those go to. I'm sure he knows.
I just think we just need to kind of push them down behind that handle
Yeah.
or something.
Yeah, we'll get them out of the way. But
Yeah.
we'll ask Ian what these are. I'm sure he knows.
Got them one wires that are bare.
Yeah, right here.
Yep.
Yeah, I don't know what that is either. Let me ask Ian. Oh, the buzzer for the MSA, which I don't believe it's up there, but it doesn't work.
Right.
So,
We need to get them taped up with something where they're not bare in there.
yeah.
Get them kind of cleaned up too.
Okay. All right. Well, that pretty much concludes the training for this.
Hey guys, Cagney Brown with the Bar Environmental. So today we're going to go over the control panel for the bar screens. We have the screen controls menu, which you go in here, gives you your e-stop, your local e-stop, your screen alarms, your triggered alarm screen. It tells you your auto call to run, is it stop, your low level float, high level float, high level float. Go to your setup points. It's got your stroke times, your auto screen, start, stop, delay times. You got your maintenance screen, which tells you your motor run time. You can reset it. It gives you all your stops up here. You got your alarm summary screen. So you go in here to reset your alarms. And it tells you what alarms you have. Your technical assistance screen basically gives you the application name, your application timestamp, all your information of who the panel and everything was created through, Lord and Company. Gives you the phone number to call, the main office, the project information. You have your e-stop here. You got your system on lights, your pump overload, your low level lights, your hot oil temp, and then you got your hand mode and auto mode.
All right, Tremont CSO training. All right. All right, so we got the overview screen. It's just the overview of the CSO structure with the channel level and 54-inch sewer and fluid level and valve positions. Status screen, this shows you all the status for your, well, it shows your levels up top, your influent gate, drain gate, junction box status. Let's see, the 84-inch sewer level, which I believe that's floats, correct? Okay. See your screen 1 and 2 status, your tipping buckets, and your screen motors and just screen status. Under controls here, this CSO is a little bit different. If your facility level is less than 5 feet, then you're filling the cells. If you're over 5 feet, then you're discharging to the river. And obviously you just control this. To run the CSO in automatic mode, put all the gates or all the valves in automatic mode. Looks like you guys run this mostly manual, don't you?
Yeah.
Okay.
And the only two that do work in automatic or open to close are the influent gate and the junction box gate.
Yeah, that's
because
right.
The drain gate didn't have enough wires or something like that to land it to the screen, so you have to physically go out there, which that's only when you drain the CSO, but you have to physically go out there and open the gate.
Okay. All right. And this one doesn't have a solenoid screen because we don't have any solenoid valves. They're not gate valves. They're all motor controlled, electric operated motor valves. Alarms. Let's see. Normal condition, they're gray. When they're faulted, they'll have a red box behind them. Alarm summary, obviously current alarms. Alarm history would be, this is all the alarms that you've had. Red's current alarm, green is cleared. All right. We have an emergency call button. It's not emergency stop, it's emergency call. All right, in here we've got our PLC, Ethernet switch, GFI receptacle, analog surge suppressors. These modules can be replaced. 120 volt surge suppressor, again the module pops out, can be replaced easily. This is your main circuit breaker. We've got 2 redundant power supplies, that's redundancy modules. This is intrinsic safety barriers. If they need to be replaced, just pop the terminals off, replace it and pop them back in. There's no dip switches, no configuration required. And that's pretty much it for this site. All right, East Bank CSO training. All right, so we've got the overview screen, which just shows the CSO structure and levels, gate positions. Interceptor screen, this shows you all the valves and equipment associated with the interceptor. Cells, this is basically just a status screen, shows you the status of all the equipment. CSO control, this is where you control the valves, auto and manual, open, close them. Effluent structure and all the equipment of the effluent structure. You got your sampling time in seconds, how many samples have been taken. You can take a sample manually. Disinfection level, effluent box level, weir height. The K value is used in the formula to calculate the flow. Just keep it at 0. Fill drain control. To initiate a fill cycle, you set the interceptor level, start filling at operator adjustable set point, and a stop filling. If it's in between those two levels, you're going to be automatically filling. You've got to have your valves or your gates in automatic mode. To drain, you press the drain button. It'll initiate automatic drain sequence. It'll wait 15 minutes once you hit the drain cycle. Operator adjustable. All the purple or pink is operator adjustable. It'll wait till the level in cell 1 is less than 0.1 or 60 minutes, and then it moves to cell 2, cell 3, cell 4. And you've got a time before you can reactivate the drain sequence. It's currently set at 60 minutes. Alarm summary is going to give you current alarms. Alarm history is going to give you all the history of any alarm you had. Green means it's been acknowledged or the alarm no longer exists. Red means it's current. And the solenoid screen, you'll see where it currently says off, it'll change to on if the solenoid's on. And this is a good tool for troubleshooting or to see what step you're on. All right, we've got an emergency call button on the front. All right, got PLC. Again, I know we make sure that the switch in here is turned to on or run with IO. All righty, we got UPS bypass switch, Ethernet switch, redundant 24-volt power supplies, redundancy module, 120-volt surge suppressor, which is replaceable. This is your main circuit breaker. You kill 120 volts to the entire panel. Let's see, circuit breakers, relays. You can force the relay on temporarily by pressing the blue button, or you can turn that flag and that'll force that relay on. Down here you've got your intrinsic safety barriers. If you need to replace those for any reason, just the terminals pop off and you can replace the ISB without there's no setup configuration, no dip switches, just replace it. And that's pretty much it.